Hello everyone, we are from the group SeaStats and our project title is Sea Level Rise Due to Global Warming. I am Siti Maryam and I'll be presenting the introduction. My group members are Farra, Ainin, Sofiya, Damia, Farhana and Iffah, Nadhirah. The problem is global warming causes sea level rise through two main processes, melting glaciers and thermal expansion of seawater. This lead to coastal flooding and erosion, damaging homes and infrastructure. To understand future risks, we use mathematical modeling, which is ordinary differential equation, help us simulate long-term changes, allowing us to compare different warming scenarios like 1.5 versus 3.0 Celsius.
Next, to translate this climate crisis into math, our team built a system of two connected equations. First, for temperature, we adapted Newton's law of cooling, where the rate of warming depends on the difference from a target temperature. Second, sea level rise was modeled as directly proportional to temperature anomaly caused by thermal expansion and melting of ice. We set our baseline at year 2025 with initial temperature anomaly of 0.551 degrees Celsius with mu 3.4 mm per year per degree Celsius from European Space Agency and positive constant K 0.02 from NASA using data from back to the Earth. To simplify our 100-year projection, we ignored short-term effects like El Nino and volcanic activity, assuming the global ocean behaves as perfectly in its system. So next, to solve this system, we use both analytical and numerical method. And analytically, we solve the temperature equation as a first order linear ODE using integrity factor, then substitute into sea level equation to obtain exact formulas. For long-term projection, we apply Euler's method with a step size of h equals to 1 year and program the equation in R. This allows us to calculate and visualize the sea level trends over 100 years. So here is our graph using data t values of 1.5 and 3.0. So now
Next, let's look at our simulation results up to the year of 2125, which are detailed in the tables. We track two distinct climate pathways, which is the first scenario 1.5 Celsius and the second scenario is 3 Celsius. Looking at the results, both temperature trajectories follows an asymptotic path. They surge rapidly in the first half of the century but begin to level off as they approach their respective targets. However, the sea level data reveals a much more alarming trend. Unlike temperature, sea level rise shows a continuous uninterrupted upward slope with absolutely no signs of stabilizing by the end of our simulation timeline. By 2125, the first scenario leads to a 478.24 millimeters rise, whereas the second scenario reaches to 767.76 millimeters. This net difference of over 400 millimeters proves a critical point, which is if we double the warming target, we effectively double the level of sea rise.
For the conclusion, we use a mathematical model using the ordinary differential equation, or we call it as ODE. We simulate the model for 100 years for 2025 to 2125 using the Euler's method. The result will show that the highest global temperature can cause the highest sea level rise. This proves that there is a strong positive relationship between the temperature and also the sea level. Even after the temperature stops to go up, the sea level rise will keep rising. If we keep the global warming at the 1.5 degrees Celsius inside of 3.0 degrees Celsius, we can also reduce the sea level rise by 289.52 millimeters. So many people living by the sea will be protected and also the small island will stay above the water. Thank you.